let's talk about something in math that just feels, well, a little weird. How can you add something but end up with less than what you started with? It sounds counterintuitive, but it's all about the power of negative numbers. And over the next few minutes, we're going to break it all down. I promise, it's actually way simpler and cooler than you think. Let's get into it.
I know, it sounds like a total riddle, right? This is the big puzzle we're going to solve today. And the answer isn't some kind of trick. It's a really intuitive idea that, once you see it, you'll kind of wonder why it ever seemed confusing in the first place.
And to get this concept to really click, we're not going to be messing around with complicated formulas. Nope, we're going to use a couple of simple, visual models that make the logic behind it crystal clear. Let's kick things off with a scenario you can probably relate to.
Okay, first up, the zero-sum game. Just imagine a really simple game where it's not just about gaining points. You can lose them too.
So here's our story. Neva's playing a game. She scores 3 points. Awesome. But then, on her very next turn, she loses 3 points. Now, we all know intuitively that she's right back where she started, at 0. But the real question is, how do we write that down using math?
Well, it looks just like this, a positive 3 plus a negative 3. This simple little expression is what we need to figure out. And to do that, we need the right tools for the job.
So to solve this and to really, truly understand it, we're going to look at the problem through 2 completely different visual lenses. You can think of them as 2 different ways of seeing the exact same truth. First, we've got integer chips. These let us physically group and combine positive and negative things. Then there's the classic number line, which helps us see addition as movement. Both are super powerful tools for making things clear. All right, pay attention, because this right here is the key to everything. It's the one simple idea that unlocks this whole concept. It's called the zero pair.
Okay, let's go back to Neva. She has 3 positive points, so we'll represent those with 3 positive chips. And she lost 3 points, so we'll show that with 3 negative chips. Now, this is the zero pair process in action. The best way to think about it is that a positive chip and a negative chip are total opposites. Kind of like matter and antimatter. When you pair them up, they're drawn together, they neutralize each other, and poof, they result in a value of 0. That's a zero pair.
So, for Neva's score, we take her 3 positive chips and pair each one up with her 3 negative chips. They form 3 zero pairs, and they cancel each other out completely. What are we left with? A big all 0. Her score is right back where she started.
So let's put a formal name on this idea. A zero pair is just 2 numbers, like positive 3 and negative 3, that add up to 0. They're opposites. The fancy term is additive inverses, just because they cancel each other out when you add them.
Okay, so the chip model totally works. But does our second model, the number line, back up this whole zero pair idea? Let's give it a test run with a similar problem. Positive 5 plus negative 5. Oh yeah, it absolutely does. It's so clear on a number line. You start at 0, you move 5 steps to the right into the positive zone, then adding negative 5 just means you turn around and move 5 steps back to the left. And where do you land? Right back at 0. It's the exact same principle, just shown as movement. Makes sense, right?
Okay, so we've established that perfect opposites cancel each other out. That's great. But you know, life isn't always so neat and tidy. What happens when the numbers aren't a perfect match? Let's see if our zero pair logic holds up with a new problem.
Let's take a football example. Imagine a team gets a great play. They gain 5 yards. That's our positive 5. But on the very next play, they get hit hard and pushed back 7 yards. That's our negative 7. So the question is, what's the result of 5 plus negative 7?
Let's break out our chips again. We've got 5 positive chips for that 5-yard gain and 7 negative chips for the 7-yard loss. We know what to do, right? We can form 5 zero pairs by matching up each positive chip with a negative one. So what's left on the table after we do that?
You got it. After we match up those 5 positives with 5 of the negatives, creating 5 zero pairs that cancel out, we're left with 2 lonely negative chips. So 5 plus negative 7 equals negative 2. The team actually had a net loss of 2 yards.
And check this out. The number line tells the exact same story. You start at 0, you move 5 yards forward, then you move 7 yards backward. You go right past 0 and land on negative 2. See? Both of our models give us the exact same answer. That's how we know this really works.
Okay, so this is all cool math, but why does it actually matter? Well, because this simple logic of combining positives and negatives, it's literally everywhere in the world around us.
Seriously, once you start looking for it, you'll see it everywhere. We've already talked about games in football, but it's also how we track temperature when it drops below freezing, how we talk about elevation, like being below sea level. It's the entire basis of finance with credits and debts, and it even explains the fundamental charges of protons and electrons in chemistry.
And just look at how cleanly the math translates. An orca starting 6 meters below sea level, that's -6, and then rises 7 meters, it ends up at +1, or 1 meter above the water. If the temperature is -8 degrees and it warms up by 15 degrees, the new temperature is +7. The logic is so consistent and so powerful.
So let's bring it all home and circle back to that original puzzle. Adding a negative number isn't some kind of strange magic. It's just combining an opposite. Whether you like to think of it as creating zero pairs that cancel out, or just taking a step backward on the number line, the logic is exactly the same. You are reducing the total value.
And that's really the big idea. Adding a negative is moving backward, which should get your brain spinning a little bit. If that's what adding a negative does, what on earth happens when you try to subtract one? Now that is a puzzle for another time. Thanks for digging into this with me.